This episode of Serverless Chats is brought to you by Stackery. This week, I'm chatting with Paul Swail about communication patterns in serverless. This is Serverless Chats, episode number 41. Hi everyone, I'm Jeremy Daly and you're listening to Serverless Chats. This week I'm chatting with Paul Swail. Hey Paul, thanks for joining me.
Hey Jeremy, it's great to be here, thank you.
So you are a cloud architect at Winter Wind Software. So why don't you tell the listeners a little bit about yourself and what you do?
Yeah, sure. I'm an independent cloud architect. I work primarily with AWS and I specialize in helping development teams ship their first serverless application into production. I've been focused specifically on serverless for 2 years or so now, although I have been doing software development professionally for about 19 years in total.
Wow, still not as old as me, but that's okay. So one of the things that you've been focusing on lately, or I think you're sort of making this transition into serverless first. So why don't you tell us a little bit about that?
Yeah. So my website is currently in the process of being moved to serverlessfirst.com. So I think that basically serverless first is a methodology which I've sort of been taking with my clients that I've been working with over the past couple of years, where they're used to more traditional ways of building serverless apps, and they see the value of using serverless, but they can't use it for everything. So it's the approach of, by default, your architectural decisions start with serverless services, unless you can justify using something else.
Awesome. All right, so I wanted to talk to you today because I don't know what happened, but somehow you've become one of the most prolific writers in serverless over the last couple of months, releasing a few articles or a few blog posts every week. And it's been awesome, right? Because every time we get more content and you answer more questions and you get deep onto one particular subject, I think it's super helpful. And one of the things that you focused on quite a bit, I think, has been this idea of, these communication patterns in serverless applications. Yeah. And you wrote 2 articles recently. One was called 7 Ways to Do Async Message Processing in AWS, and another one was Inter-Service Communication Channels for Serverless and Microservices in AWS. So both great articles. Definitely go to winterwindsoftware.com, check those out. Very, very interesting stuff. But why don't you tell us a little bit, and maybe you can get us started in terms of what are the main communication patterns in serverless, and why is it so different maybe than a traditional application?
Yeah, I think working with clients, a lot of my clients have come from the monolithic architectural background, and like asynchronous stuff, they may be aware of it, but they haven't used it a lot. So AWS has a lot of services which around asynchronous messaging patterns, and it can be hard to understand what to choose. So a lot of it is just sort of documenting questions that clients have had for me. A lot of the writing is around that area. So we can go through the details of lots of individual services that I discussed in the article.
Yeah, but so let's start though, maybe just thinking about the difference between asynchronous and synchronous, right? Because I think most people are very familiar with that monolithic approach and I should maybe take a step back. They're used to that request response type mechanism, right? Mm-hmm. I make a request to a website or to an API, and that data comes back to me. So there's that one part, sort of that immediate response, and that's not going to change whenever you have a customer facing or a web facing side of things. But it's where the back end, the back end is what gets different, and that is one of those things where I think when people are familiar with monolithic applications, they think, hey, I've got 15 different methods or functions or whatever that are all in one big application, and I can say, hey, I need to process the order, I need to pull the inventory, I need to send the message, and that's all in one app, or one, I guess, big chunk of code, really. But when you start moving to this asynchronous thinking, we're starting to separate out these components separately. So what do people have to think about when they start building that type of application?
Yeah, there are quite a lot of things to think about. So I guess a lot based on those the workloads. Firstly, if it's like a task or a job based type workflow you may want to do, or maybe that you need to notify a lot of other systems. So based around that's a decision in itself around what service you use based on the nature of the workload. There are a lot of sort of operational considerations, such as around throughput, concurrency requirements, latency requirements, scalability of any downstream systems that you may need to talk to, message durability, your error handling and retry mechanisms. So these are all things of cost, of course, as well. So these are all things that you need to consider around how you would structure any asynchronous messaging patterns that your workload requires.
Yeah, and I think that makes a lot of sense. And I think what you get people sort of coming from the monolithic space or the traditional system space, and they move into distributed systems. Now there's this whole different idea of passing messages around, right? Like we're no longer using a single system, so now we're trying to communicate with multiple systems. And as you said, things like durability of messages, that becomes a huge concern, or something like the error handling, right? Like what happens when you send a message off into the ether and then you don't know what happens to it, right? Like, I mean, does it ever get to its destination? How do you know a message was even sent if that information isn't recorded correctly? So I think maybe that's another thing that is interesting to me, though, is that even people who are maybe come from distributed systems and think about, oh, well, I've got to set up a Kafka cluster, or I've got to do something like that, that traditionally there has been a ton of stuff that you would need to do just to create the messaging components between these distributed systems. But serverless changes that quite a bit.
Yeah, it does. I can echo those sentiments you said. Like I used to, back in my Microsoft.NET developer days, like setting up BizTalk servers, like something actually I knew how to do, and we did it in a few projects, but just the provisioning and management overhead of doing it, even though it was a nice distributed messaging pattern, it was just so much effort to manage. Whereas with AWS serverless async services, like it's just create a few lines of YAML and SLS deploy or whatever tool you're using to deploy it, and there away you go. The operational overhead is just significantly less.
Yeah, I think that makes a ton of sense. And when you're setting up, these distributed applications using serverless, and you're using one of these, say, pub sub services, for example, like SNS or EventBridge, it makes it really, really easy. So maybe let's talk about pub sub for a second.
Yeah. So for folks who don't know, PubSub is it's a system where you're a publisher and a subscriber. So it's a way of decoupling separate services. If you even think of your application as having separate services, and you can something happens in service A, and you can just publish an event. And service B may need to do some processing on that. It can consume that event, but the actual message communication between those is managed by a pub subsystem. And within AWS, we have sort of two main pub subsystems with SNS and EventBridge. I've been using SNS for a few years now. I've just started using EventBridge. They're very similar feature set, although EventBridge seems to be the preferred solution amongst most serverless experts these days. I think mainly around it offers more event targets. And it had a particularly nice feature is around the schema registry. So a big thing with PubSub is your different services. There is a small coupling around the actual schema. They are literally coupled, but they do need to know what shape the message is going to be. The schema registry that EventBridge provides gives you a way, if you're using a typed language such as TypeScript or Java, you can download type definitions based on the events that are getting sent to it. So it means your consuming application knows exactly what to expect, and you can at compile time you know how to work with your messages.
Yeah, and I think as you said, it's I think things are going to move to EventBridge. I think we've seen a lot of sort of noise around this, and I've been using EventBridge in production now for several months, and there are some really, really cool patterns that you can do. just with the huge throughput. I know there's some concerns or some talk about some latency issues and things like that, but it also depends on what your workflow is. But SNS still has its place, right? So SNS still a great pub sub service that you may need to use. So let's talk about the benefits of using asynchronous versus synchronous, right? Because I think that most people, again, going back to that monolithic example, it's all right, an order is placed, so I have a function or a method in my system called process order, and then process order has to do the inventory, it has to do the billing, it has to do the messaging, it has to do the invoice creation or some of these other things, and that all happens by using just internal method calls or whatever, and easy to call those. When you start switching over to distributed systems, even you might have a billing service, you might have a invoice service, you might have a alerting service, and that is all sort of a simple way to think about it if you're doing sort of like a container-based system, and you might want to do asynchronous communication that way. But when you're using serverless, we're breaking it down into even smaller functions and things like that. So, but what are those benefits? Like, what are the benefits of being able to split those up into jobs that don't have to immediately give you a response?
There's several benefits. The first one benefit is that simply it's sort of easier to reason about. If you've a single task as a developer, you can see just by reading it what it's actually doing, rather than having a huge, as you said, a single function which does the orchestration of all the things within code. So, and from a logging point of view, from a monitoring point of view, like say within AWS CloudWatch logs, exactly. You can go into the functions logs just to see exactly what happened or what went wrong. If a major benefit is around retries, so say you have a multi-stage workflow, and one of the say steps A through A, B, C, and D. So say step A succeeds, step B fails. So you don't want to, if that was a single Lambda function carrying out all those 4 steps, then how would you would either have to retry it all, or you have to build it all into your logic, how that gets handled. If you split it up into 4 separate asynchronously invoked lambdas, the Lambda service itself will do the retries for you. So in my example there, step B, say it fails, Lambda will have completed successfully, that's done, but B will be automatically retried if you so wish it to be. So that's another benefit around the errors and retries. And the obvious, probably the most obvious one, which I forgot to say, is just around latency. So if you have a user-facing API call, if this is all behind, then the user probably doesn't need to wait for all 4 tasks to complete. Whereas if you have an API gateway call, right, you can just write it to a queue or write it to a pub subsystem and just return to the user, and all the rest of that processing happens in the background, and the user gets a quick response.
Yeah, I know. I totally agree. I think that's one of that idea of immediate response is huge. I mean, because everybody wants stuff back quickly, and there's no reason why that invoice or that credit card has to necessarily be processed immediately. I mean, you submit an order on Amazon and it says we've received your order, and then you usually get something later on that says, oh, we couldn't bill your credit card or something like that. The other thing, though, I think that is really great about splitting things up into separate functions is this idea of sort of not only the security aspect of it, where each one can be finely tuned or finely tuned security, but also this idea of being able to scale each one of those things independently.
Yeah, that's right. So if you have, say, one of your tasks talks to a downstream system, say in an RDS database or a third-party API, which may not scale as well as serverless services, you may want to sort of throttle it. So using the async, say for the likes of an SQS queue, you could use that to throttle your throughput to that system. And equally, so that's sort of scaling down as such. But you can also, if you don't need to do that, you can use SNS and just have a fan out pattern to to distribute it as widely as possible. Say if you have a task which is splitting out and right into Dynamodb or something which can match the scaling that Lambda would give you.
Right. Yeah, no, I think that, I mean, I do a talk on this about downstream systems not being able to handle, not being able to handle the amount of pressure that might come from a certain workload. And I think that's actually a really important thing to consider is the great thing you have with just putting concurrency on a particular function is to say, look, I only want 50 concurrent connections, or I only want 100 concurrent connections. And that could seriously help when you're trying to throttle against a downstream API or like you said, an RDS cluster or something like that. But that's one of the things too that I think is where people get a little bit confused. They say, well, normally if I make a request to an API and I've got to call the billing service, somewhere in between there, if that thing is being throttled and I have to respond back to the customer and say, hey, I'm throttling this, that's a bad experience. But with the async piece here and putting something in between, like SQS, for example, to be able to store and create message durability, that is something I think where people get a little bit lost on how that kind of works.
Yeah, it can be quite confusing, and I guess if you want to do a full sort of asynchronous back to the user, like in that example, you could even introduce WebSockets. You could have the initial API call from the client just writing to the queue, have all your async processing happening server side, and then separately do a WebSocket push back to the client once it's ready.
Yeah, no, that makes total sense. All right, so let's talk about billing for a second. So how are you seeing with your customers sort of their reaction to this pay-per-use billing? Because I think in most cases, we're not afraid of these 5-cent Lambda bills, but when you start adding on API gateway and things like DynamoDB and SQS, I saw an article the other day where it was this application where Lambda cost 1 cent and SQS cost $1.83. And so again, it gets other services besides just Lambda get kind of expensive. So how are your clients seeing this and sort of, I guess, planning for the cost?
Yeah, it's more with serverless. It's more about the variability than the actual absolute price. So, it's generally low and it's generally negligible in a lot of definitely in pre-production scenarios. But it's the variability of especially with the large asynchronous workloads, which can like fan out to lots of invocations. So a lot of the times the client comes. Because one of my clients they're a dev agency themselves, so they build a lot of apps with totally different workflow patterns. So at the start of each project, we would sort of often it's just in an Excel spreadsheet, just plugging figures in to see based on expected usage or what our current architectural design. There is this how much it can be. It could vary quite significantly. Yeah, I mean, API gateway is one of the most variable of the serverless services, but sometimes clients have existing EC2 infrastructure as well, which gets hit. But yeah, API gateway. I know you did an episode recently with the API gateway team with the new HTTP APIs. Mm-hmm. So I haven't tried those out. So hopefully that will. I think there is it. 33% of the cost, so yes, hopefully that will help out on that front.
A little bit less, actually. I think it's $1 per million as opposed to 350. So no, and I mean it actually. You bring up API gateway. I mean, I think one of the things that we can't lose here, and we mentioned this a little bit earlier, but that there are still synchronous use cases, right? Like we can't mm-hmm. just throw away synchronous altogether, and sometimes synchronous might not be. Might not just be the front end web API. Like we might need synchronous invocations, and in most cases, even an asynchronous process needs to make a synchronous call to something like the Stripe API or maybe to another microservice. So, mm-hmm. What are some of the pros and cons, though, of using? I mean, we certainly don't want to try to chain synchronous invocations, right? Like we don't want to call our API through API gateway, then make a call to some other service that makes a call to another service. I mean, decoupling those, I think makes a lot of sense. But you can't always get around that. So like, what are some of the pros and cons of some of those synchronous patterns?
Yeah, I guess it's the client gets an immediate response. That's sort of, if the client needs an immediate response, you can't, like, if it's just simply fetching from a database, that it has to be synchronous. If it's a GET request, an HTTP API, but I guess a benefit, it's off. You could say it's easier to reason about. So from a developer debugging point of view, I still would find that, say, synchronous calling patterns, the logs are generally easy to find. You don't need to look through log files for separate Lambda invocations often. So from that point of view, synchronous is still easier to monitor and to debug, I would say. You could possibly argue that it's maybe easier to author in the first place. Well, for developers who like writing JavaScript code or Python code or whatever, rather than lots of YAML to configure, those guys would be probably happier writing simple synchronous code. But yeah, we try to move folks away from that. But yeah, but generally I would recommend, if you don't have to, like, if you can do it asynchronously, do it asynchronously. Like, write something to, if you've got a HTTP, a user API, just write something to a queue or to SNS or to EventBridge or to Dynamodb, and yeah, just return and have any other processing done in the background.
Yeah, I think especially when it's post request, right? Any type of write request, you can return something back, even if it's if you have to return an ID back to somebody, then generate a UUID and return that, and also submit that with the job so that gets associated with that job and you can look it up later or something like that. So but I mean, if it's a GET request, right? I mean, there's a lot of caching that you can do. I think people don't take advantage of the CloudFront caching through API gateways, like, and how you can actually change the amount of time something gets cached for, so you can minimize impact on the APIs. There's a whole bunch of interesting tricks that you can do there. Hey everyone, I just wanted to take a quick moment to thank our sponsor, Stackery. If you're building serverless applications on AWS, you have to give Stackery a look. They've built a next-generation SaaS platform that lets you securely develop, deliver, and manage serverless apps quickly, consistently, and at scale. It doesn't matter if you're building greenfield or refactoring existing monoliths, Stackery streamlines and organizes your AWS SAM and CloudFormation templates, environment configurations, and credentials. This creates a development workflow that not only makes sure everything is properly configured and instrumented, but also increases engineering velocity by 60x. They provide a CLI, VS Code plugin, and IDE extensions that let you locally debug any Lambda in any language or framework, even against your remote cloud resources. Stackery gives you architecture visualization, one-click access to tracing and logs, local debugging, and so much more, letting your team focus on app architectures and business logic, not YAML. Chase, Farah, Danielle, Tim, and the whole team over at Stackery are awesome people, and they've built an incredibly useful product. So for more information or to sign up for a free developer account, go to stackery.io. That's STACKERY.io. So another thing, though, that comes up is, once you start using multiple Lambda functions, is this idea of function composition, right? And so we talked about the asynchronous patterns, where sort of one function generates an event, maybe that goes to EventBridge, and then another one is listening to it. But what are your thoughts on Lambdas invoking Lambdas? And there's two ways to do it, synchronously and asynchronously, but maybe your thoughts on each.
Okay, let's take synchronously first. Generally avoid against this, but yeah, the reason why it's not, I would generally say don't do synchronous Lambdas, is because say you have Lambda A invokes Lambda B and it's waiting on the response. As soon as that invocation happens, you've now the clock is running on the invocations of two functions, so you're paying twice for both functions being running. Also, there is it can be quite difficult. That you have also two places to look for the logs as well. So people who are fond of reusing functions, like functions at a code level rather than the Lambda function level, they may, when they're first coming to Lambda, they may think, oh, I've got this piece of functionality which I want to reuse, I can just create a Lambda function for that and call that from all the other Lambda functions where I need it. But generally, that's not what you want to do. And just use a code module or a code library and reuse it in that way. So that's the synchronous. Actually, there's one exception where I have done it, invoked it synchronously. That is when I'm using VPC. Now it's pretty low. I have a schedule. I had a use case recently where I have a scheduled job that runs nightly. It's for a SaaS app that sends out nightly emails.
Yep.
But to do that, it needs to query an RDS database, which is inside of VPC, and send it out to all the users with who match a certain where clause. So there's sort of two things going on there. There's a CloudWatch rule to trigger a Lambda. Then there's a database query, and then there's I think I was publishing to SNS or using TSAS to send the email at the end. So but if I just had that as a single Lambda running inside a VPC, I can't then call the email service or so in that case I put a Lambda inside the VPC just to do the query, the database query, and the calling function, invoked that, got the result back, and then it was able to send the email because it had internet access. So that's the only sort of exception where I think it's valid to do that, but some people may argue that's not even valid.
So I actually think that's a really good use case. I mean, the only other thing I would suggest is maybe use like the RDS data API if you were in a Aurora serverless database, then that way you could use, and actually that's one of the things that I do. I have a reporting service. I have this I think it's a cool setup where basically all these operational front ends are DynamoDB. They have Dynamodb Streams attached to them that replicate the data to an Aurora serverless cluster. And then there's a reporting service that runs queries against that through the data API. And surprisingly, it's extremely fast. The data API, that's not the fastest sometimes when you're doing synchronous stuff, but it works pretty well. And then of course it avoids that VPC issue. But you mentioned this idea of separating functions, like as you said, maybe that what you might consider code modules or code libraries, where like again you might have a function that is charge credit card, and you might have another function that is create invoice, and using these same examples. But there's a really, really good argument, and I know Lego does this, I know that Bustle does this, where they create these fat lambdas, right? Where lambdas do more than one thing because you need to have that synchronous component. Now, maybe the one I just mentioned is probably not the right idea, but there are times I think where you don't want to be calling lambdas between lambdas in most cases. But if you do find yourself needing two separate pieces of logic that need to happen asynchronously, this idea of fat lambdas is, I think, really interesting. Where you just put these two things together and say, I'm going to run these two snippets of code in the same Lambda function because I get the benefit from that.
Yeah. I would do it like that. I don't even know if I would, because sometimes I guess fat lambdas can be misunderstood to be. I wouldn't even call that a fat lambda as such. I guess it's just well, I break lambdas into three categories. I have the single purpose function, right, which is the one that we that I think we try to favor. Then you have the fat lambda that takes multiple bits or multiple actions and puts them into a single function to optimize it. Then you have the lambda lith, which is sort of your entire application runs in a single lambda function. So I think fat lambdas are an optimization and not necessarily a bad pattern, because sometimes you need to do that. Oh yeah, absolutely, yeah, and yeah, there's no point in being dogmatic about just. I would generally say single purpose lambda functions, but yeah, if it's something which will always have two natural steps, right, and it doesn't make sense to split them apart into their own lambdas, then yeah, go for it.
And when it has to be synchronous, So the other time I think that a synchronous API call to another Lambda function isn't the worst is if you're doing inter-service communication and you need a synchronous request. So if you have a a customer service and you have an order service, sometimes that order service needs to look up that customer. And when that happens, you definitely don't want to route that back out through an API gateway or something like that. That just gets overly complex. You do build coupling in, but you build coupling in on all kinds of things. Because think about if you're calling the Stripe API or you're calling the Twilio API, your service is bound to or is coupled to that other API. And I think that's okay in certain circumstances as long as you have the fallback methods in place. So if you were going to, say, process an order and the order API or the order service has to call the customer API, that is fine as long as you, again, maintain some sort of contract between the two, but also knowing that the order API or the order service could fail that particular call and then retry, maybe once that other service comes back up. And of course, you'd want to do circuit breakers and all that kind of stuff in there. But what are your thoughts on that?
Yeah, I think that's a totally valid pattern. So if you have the two separate services, I guess, if you don't want to introduce the coupling, you could somehow have an event-based model where each service keeps a copy of the other's data as such, so it doesn't have to do those synchronous calls. But sometimes that introduces problems itself, just keeping the data in sync as well.
Well, you got to get the data the first time, right? So I mean, it's okay to maintain a copy of the data, but you still have to get that data the first time.
Yeah, well, I guess you could have They could have an event-based pattern where the service with the data in the first place could publish an event, and
I see what you're saying. Yeah.
You could transfer it asynchronously like that. But I'm not a massive fan of that approach either. So sometimes it is just easier if to do that, make that synchronous call, as long as you don't have too many. If it's one or two between a service, that's okay. Once you have more sort of synchronous inter-service channels, then that's where you're sort of losing the advantages of having microservices at that stage.
Right. Yeah, I agree. Because too much coupling definitely can cause some problems. So what about the asynchronous calls of other Lambda functions? Because one of the complaints that you sort of hear about this is even if you are sort of chaining Lambda functions and everything is happening asynchronously, that you are introducing a lot of coupling, and then you really reduce the amount of reuse that you get from a single Lambda function.
I can understand the reasons for that. I guess I don't know if you're alluding to there's Lambda Destinations recently, which have a few months ago AWS announced it. So by that you can configure any asynchronously invoked Lambda functions. You can configure another Lambda function to take the result of the first invoked function and pass that into the event of the next one. That coupling, I can see it, but there's from a reuse point of view, I'm not sure. Can you maybe directly? I think you can still synchronously call the function.
Yeah, you could. And actually,
and have that scenario, and you won't get the side effect of the destination being invoked.
Right. Yeah, and I should clarify this too, because essentially the point that I'm getting at is that if you hard code it into your code, right, and so every Lambda function that gets every function that gets invoked, regardless of whether it's synchronous or asynchronous, is always going to have a hard-coded next step, right? I mean, you could put a whole bunch of logic in there if you wanted to or whatever, but there's always that problem of that function getting invoked synchronously, asynchronously, and then something happening where then that next call doesn't happen, which is where Lambda Destinations comes in. I love Lambda Destinations. I think it's a great pattern to have another Lambda function or, in most cases, Event Bridge or something like that respond or be able to handle the output of an asynchronously invoked function. But I think I'm talking more about sort of hard coding that workflow into Lambda functions to say when this Lambda function is done, then it calls this Lambda function. And then when this Lambda function is done, then it calls this Lambda function. I think you introduce a whole bunch of challenges with that approach.
I guess you do. And I guess there is step functions, which for certain workflows, that makes sense to solve that problem. So if you have a workflow which is pretty well defined in a bit like a business workflow, it may make sense to you could put individual Lambda functions together via a step functions state machine,
right?
And from that you can still invoke the individual Lambda functions separately if you need to. Otherwise, or you can use the step functions to compose to pass the output of one to the input of another, or to fan out, or sort of more complex mechanisms if you need to.
Right. Yeah. And in step functions, again, I say this all the time, but for complex workflows, step functions are great. And again, for function reuse, and that's one of those things where if you think about your traditional monolithic application and you say, I got to process the order, charge the credit card, create the invoice, do all these things and all those steps, and you need all of those to complete, and you need that guarantee. If you can do that asynchronously, meaning that you don't have to immediately respond to the client and say all this stuff is done, which again, the more complex systems get, the easier it is to, or the harder it is to respond in a short amount of time. Then using something like step functions is great, because then you can basically set up your retries separately. You can if something fails, or a whole pattern of them fails, or a whole bunch of them fails, you can implement a saga pattern, and you can go back and unwind all of them. So there are a lot of really cool things that you can do with step functions, and they're all invoked synchronously too. So you know exactly what's happening as that state machine is processing it. All right, so when we get beyond just regular, or I guess basic messaging between systems in distributed systems, and more so in serverless systems, we've been talking about passing messages back and forth and invoking one Lambda function at a time, or things like that. You kind of mentioned polling, or you mentioned SQS and some fan out and some of those things, but that's another thing that is a very powerful way to communicate or to build distributed systems, is to use queuing or streaming or some of these things. So we obviously have SQS queues, we have Kinesis streams, and we have Dynamodb streams, things like that. So just what are the just I guess for the benefit of the listeners, what are the differences between those, and maybe when and why would you use different ones?
Yeah, the benefits of Kinesis is that you get a long backlog of events. So as an example, I have a SaaS product which has website click tracking. So events coming through from different websites, at a high throughput. So we need to capture them quickly. But the processing doesn't need to happen that quickly. So the processing can happen gradually. Mm-hmm. So we have a long backlog. It gives you a long backlog potentially of events, and it's similar to the way a queue does. But unlike a queue where you just have a single processor pulling items off the queue, with a stream you can have multiple subscribers. So in a way, it's sort of like a combination between a queue and a pub sub in that respect. We can have multiple subscribers processing messages off the stream, although other consumers can consume that same message. Mm-hmm. So based on that, Dynamodb Streams is similar in that if you already have an application, you're using Dynamodb as your application database, but you need to react based on certain data that gets put into your system, Dynamodb Streams might be a good fit, in that it gives you an asynchronous event model based on an item is added or updated or deleted in your Dynamodb table. You can then, in a separate job, get notified about that event and then do whatever processing you need. I guess a drawback of using Dynamodb Streams is that the event schema that you get is quite specific to Dynamodb. Mm-hmm. So it's in your Dynamodb item, your consuming service needs to know effectively your database schema, whereas it's not a nice friendly domain event schema.
Right. Yeah. Well, and I think the other thing too is that as you mentioned, the ability to process the same message twice is sometimes something you want to do with Kinesis or with Dynamodb. So you might want to have multiple consumers reading that same backlog, as opposed to something like SQS, where you can have multiple Lambda functions or parallel Lambda functions reading those things off the queue. But once you read the message and remove it from the queue, it's gone. So it just takes the message out of the queue. Whereas those streaming services, like you said, they give you they store the events for a certain amount of time. You can go back and you can kind of read. You can kind of read through those things. So yeah. So I mean, again, it depends. I mean, when would you suggest somebody use, say, an SQS queue over Kinesis?
I guess in most cases, SQS, I would default if you have a job like which needs one-to-one processing, you're only ever going to have one downstream processor. Then SQS makes sense, but it's proper serverless pricing, pay per use, which unlike Kinesis, Kinesis charges like by the hour based on how long it has a shard based pricing model. So you're paying by the hour rather than per use.
Yeah.
So in general, if I've used in my applications for my own and for clients, I've used SQS a lot more than I have Kinesis. But I guess if you have that large volume of events coming in, that you need multiple processors to need multiple subscribers to, then Kinesis certainly makes sense in that respect.
Makes sense. All right, so let me ask you one more question about developers building asynchronous applications. So a lot of things to think about, right? A lot of pitfalls whenever you're building a new type of system, and of course, a lot of pitfalls in distributed systems. So what are sort of the main things that somebody that's now building things asynchronously really has to think about? Like, what are the big ones you have to be wary about?
Yep, there are a few things. So number one, I would say distributed tracing. So if you have a multi-step use case where there's a lot of data processing going on in the background, you probably now have multiple log files to search through. So there are that if you were doing that synchronously, you could just look into one place more often than not. So there are strategies around using correlation IDs within each message, so that say in CloudWatch you can query on for that correlation ID and get an aggregate of any log entries across your different log groups which have that correlation ID within it. But you need to build that into your application, your Lambda code. That doesn't come out of the box. Another consideration is testing or writing automated tests. It's just harder for asynchronous workflows. So if you're writing a synchronous, say I write in Node.js and Jest test framework. So if I have a synchronous Lambda, it's generally pretty easy to write an integration test for that. You just hit the endpoint or invoke the Lambda function or whatever, and just verify the response. But if you have a multi-step, multi-step asynchronous data processing workflow, then you need to test each one of those individually. Doing an actual writing an end-to-end test is difficult without just like having wait a step which just waits for until background processes have completed, and then you can do whatever verification steps you need. And just generally understandability. It's not a thing in itself, but it just for if you've got a new developer on your team, and a lot of teams that I've worked with are sort of more like a full stack web developers, but which are used to monolithic sort of synchronous workflows. They're get a new guy on your team, and that's just explaining to them how each piece of the pie fits together. That's just going to take time, and documentation really is the only solution to that. So it's just good documentation is important when you've got these asynchronous workflows.
Yeah, well, I mean, the good news is that distributed tracing, there's a lot of options out there now to do that. But writing good tests and writing good documentation, unfortunately, that's a challenge, I think, for most organizations. So anyways, well, thank you so much. Let's leave it there. So Paul, thanks again for being here. Really appreciate you sharing, all your serverless knowledge. The amount of stuff that you've been writing is awesome. Really enjoy it. New tips every, couple times a week. It's great. So how do listeners find out more about you if they want to subscribe to your newsletter or some of those other things?
Yep, that's great, Jeremy. Thanks for having me. It's been you can get me on social media, on Twitter and LinkedIn at Paul Swail, SWAIL, and you can get my website. It's serverlessfirst.com. My newsletter's there too.
Awesome. All right. Well, I will get all that into the show notes. Thanks again.
Super. Thank you, Jeremy.
And that's this week's Serverless Chat. I want to give a huge thank you to Paul Swail for being my guest this week and to our sponsor, Stackery. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/41. For more Serverless Chats, subscribe, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.